what we are going to look at today is the theory part for big data. So we won't have any practical sessions for today, so it will be just as looking at this theory part for big data. So it will be a short session also. So let's begin. So what do you understand by the term big data? So as the name suggests, so big data is a collection of data that is huge in volumes. So by huge in volumes, it means that this data is being generated each and every second, and you cannot analyze this data by using the traditional ways of analyzing data. So that is by the use of Excel and maybe Python, the basic Python as it is. So you need to work with complex tools to do this. So let's see what is here. So big data is a collection of data that is huge in volume, yet growing exponentially with time. So it is a data with that is so large in size and complexity that none of traditional management tools can store it or process it, efficiently. So big data is also a data but with huge size. Okay. So let's proceed. So what is an example of big data? So an example of big data I can show you here. So what we have here is an example of big data. So each and every second we are having data being generated here. So we can go to the 1 minute chart and you can see here each and every 1 minute we have data being generated. So you can extract this data for minutes, days, and months. So you can see it goes for days, minutes, and even months. So for example, here you can see we have how many months of data. Let me check. So if we go back in time, we have okay, so we have 58 months of data. So if you divide these 58 months, so how many data points will you have for the 1 minute? So it will be quite a lot. So this is the first example I've given here, the New York Stock Exchange data. And this is how the New York Stock Exchange data looks like. So for example, if we look at this, so up here, you can see we have the open price, we have the high price, we have the low price, and we have the closing price and the percentage change. So for each and every minute that we have, so you will have that, okay? So that's an example of big data. So another example will be social media data. So for example, Twitter or X as it is called at the moment, whereby we have more than 100 tweets coming in each and every second. So it's not even more than 100 tweets. So it could be even more than that. So I don't know the exact number. Or a jet engine that can generate 10 terabytes of data in 30 minutes of flight time. Yeah, so those are some of the examples of big data. So what are the different types of big data we have? So we have the structured, we have the unstructured, and we have the semi-structured. So in most cases, you will find big data in the unstructured format because that's how it is. So for example, for the jet engine part, it's unstructured. So let's go through each and every type. So we have the structured data. So any data that can be stored, accessed, and processed in the form of a fixed format is termed as a structured data. So for example, if you have Safaricom transactions, so that's a structured data because you have labels for each and every data value that you have there. So for example, the time when the transaction was made, the amount, the recipient, and the sender. So that's an example of a structured data. Over the period of time, talent in computer science has achieved greater success in developing techniques for working with such kind of data where the format is well known in advance. So just as I've given you an example of Safaricom data. Okay. So, and also deriving value out of it. So, however, nowadays we are foreseeing issues when a size of such data grows to a huge extent. So, typically sizes are being in the range of multiple zettabytes. So, that's something you can't hold on your personal PC. Okay, then we have unstructured data. So, any data with unknown form or the structure is classified as unstructured. So in addition to the size being huge, unstructured data poses a challenge in terms of its processing for deriving value out of it. So a typical example of unstructured data is a heterogeneous data source containing a combination of simple text, files, images, and videos. So for example, YouTube videos, that's a form of unstructured data. So you can't really derive info from them, not unless you process them in a deeper manner. So nowadays, organizations have wealth of data available with them, but unfortunately, they don't know how to derive value out of it since the data is in its raw form or unstructured form. Then we have semi-structured. Semi-structured data can contain both the forms of data. So we can see semi-structured data as a structured in form, but it is actually not defined with a table definition. So for example, like what we have in Excel, so it doesn't have such kind of a structure. So example of a semi-structured data is represented in an XML file. So maybe I can show you an example of an unstructured data. So if I open maybe Google, so from your eyes here, you can see that here we have a search bar, and I head over to the New York, or let me open something I usually use most of the time when doing my analysis, and that is Forex Factory, then calendar. So here we have data that I always check on a daily basis. So for example, if we open today's calendar of events, you can see we have some data sets here. So if I go to the back end of this site, so I click on inspect, if I expand this, so if you check here, you can see that from your raw eyes, you are able to see that this is ISM services PMI, right? But here on the back end, how would you extract that data? So how would you define this data? So for example, you'll have to dig in deeper and see that this is ISM PMI combined with some other texts that are irrelevant. And what were they reading? So for example, this value 54.45. So how will you get that value? So you'd have to expand these further to get that 54.45 value. Okay. So that's actually what I'm doing here. So here you can see we have the 52.5, the 52.7. So these values are hidden somewhere in between these irrelevant texts. And that's what we refer to as semi-structured data. So it's data that is structured, but not in a well format whereby if you are reading it from the back end, you won't be able to like understand what is there. But if you are reading it from the front end, you can understand what is there. So this is an example of this is the HTML code. So close to the XML file. Let's proceed. Then what are the characteristics of big data? So we have volume. So already the name suggests that this data should be big in size, variety, velocity, and variability. So variety, it means that this data comes in different formats. Variability means that it can change at any time, so it's not that much consistent. Then velocity means that this data is being generated at a fast pace. So let's check the theory part that is there. So volume, the name big data itself is related to a size which is enormous. So size of data plays a very crucial role in determining value out of data. Also, whether a particular data can actually be considered as big data or not is dependent upon the volume of data. Hence, volume is one characteristic which needs to be considered while dealing with big data solutions. Then variability. So variability refers to the heterogeneous source and the nature of data, both structured and unstructured data. So during earlier days, spreadsheets and databases were the only sources of data considered by most of the applications. So nowadays, data is in the form of emails, photos, videos, monitoring devices such as CCTVs, PDFs, audios, etc. So each and everything that you are seeing out there can be a potential data source. Okay. So consider Okay, so the variety of unstructured data causes certain issues of for storage, mining, and analyzing data. So we don't have tools that are there in place to help us analyze these big data in a way that is more efficient and in a way that we can extract insights from them. So this is a challenge as of now. Then velocity. The term velocity refers to the speed of generation of data. So how fast the data is generated and processed to meet the demands determines real potential in the data. So big data velocity deals with the speed at which data flows in from sources like business processes, application logs, network and social media sites and sensors. So we can say, for example, if you look at Safaricom, so they are having transactions come in each and every second. So now, as we are speaking, someone is making payment for food, someone is making payment for rent, someone is receiving payment for something, or someone is sending money to their relatives. So each and every second, a new transaction is being done. Then we have variability. So this refers to the inconsistency, which can be shown by the data at times, thus hampering the process of being able to handle and manage the data effectively. So for example, if you are working in Safaricom, you might note that during the end month, we have lots of transactions coming in. And why is this so? Because people are being paid their salaries, so you should expect the transactions to come in more faster and in large volumes, and the amounts that are being transacted should be big also. Okay, so those are the inconsistencies that you will note in your data. So we have instances where the transaction amounts will be high and the transactions volume will also be high than expected, and we have days where the transactions amount will be low. So that's just an example. So in summary, we've looked at the introduction to big data and you've seen what big data is. We've checked some examples of big data. So that is the structured, semi-structured and unstructured data. And we've looked at the characteristics of big data. So on your end, what you can go and check is what are the advantages of you working with big data. So that will be an assignment for you. So before we end the session there, so I want us to look at some of the things that we will be using to analyze big data. And the tool that we will be using is PySpark. So PySpark is the tool that we will be using, and this documentation site will be our friend when we will be learning the PySpark library. So I'll share this link with you, and what we will be looking at is, so we will start by the quick start guide, how you can create a PySpark session, how you can import data, and how you can show your data, and how maybe you can interact with that data. So you won't be this won't be an interactive session. So I'll share a Jupyter notebook that has the code already, and I'll be explaining what is there. Then if you want to go ahead and try it on your end, you can go ahead and do so after the class. Yeah, so that's all for today. Any questions concerning big data? Any questions?